Hi pals, it's nice to have you around for another exposition. Today we're going to be looking at basic operations on surd. Now I've been on this series for quite some time. We've worked on a couple of things. We've worked on the various kinds of surd that we have. We've worked on a whole lot of stuff in it, but today we're going to be continuing from where we stopped. So today we're going to be looking at the basic operations on surd. Now there are different kinds of operations that are divided into two categories, which are the addition and subtraction and the multiplication and division. But today we are just going to be looking at addition and subtraction, and for the other one we're going to be looking at only multiplication. Now before we work on the division, we have a couple of things to learn before we work on the division of surd. So first of all, addition and subtraction of surd. Now before you could add and subtract two or more surds, now there's something you have to know when it comes to addition and subtraction of surd, which is this: the radicands have to be identical. So just like your algebra, now when it comes to adding two or more sets together, the radicands have to be identical. Now when the radicands, or if the radicands are not identical, there's no way we'll be able to add or subtract such surds. So when we talk about radicands, I'm very sure that you should know what radicands are, because we've dealt with all this already in the previous exposition. So look at this very example: 2 root 3 minus 3 root 3. Now how do we solve this? Is it possible for us to take away 3 root 3 from 2 root 3? Now don't forget that the very, very important rule you have to take note of is this: the radicands have to be identical. So for the 2 root 3, this is the rational number, this one is rational, this is irrational, or we call it the radicand. So this is a mixer, this 2 root 3. What kind of radicand do we have here? We have root 3. Why the 3 root 3? What kind of radicand do we have here? We have root 3. So the radicands are the same thing, just like having 2x minus 3x. So when the radicands are the same, it means we can combine the plus 2 and minus 3 together. That is, we can combine the rational numbers together. So 2 minus 3, what do we have? We have minus 1. Then we put our root 3 there. So what does that mean? It means we have minus root 3. Example 2, 3 root 5 plus 3 root 2. Is there any way we could combine this together? Can we combine them together? And don't forget that before we could solve this, when it comes to addition and subtraction of surd, there's no way we can do anything without having identical radicands. So the first question is, are these radicands the same? This root 5, this root 2. So it's this more or less like saying 3x plus 3y, which is not possible. The only thing we can do here is to factorize. There's no way we can combine this stuff together. So this root 5, this root 2. So 3 root 5 plus 3 root 2 will give us still the same thing. It's going to be 3 root 5 plus 3 root 2. There's nothing we can do. There's a final answer. Right here is the third question, which is quite complex. This root 27 minus root 20 minus root 48 plus root 45 minus 7. Now we have here a combination of subtractions and addition. So the first thing we're going to do here is to convert each of this simple surd to convert them to mixed surd. We know how to go about that. That's very simple. We've done that already in the previous exposition. So we're going to break down root 27, break down root 20, break down root 48, break down root 45, and when we're done with that, we combine them together using their radicands. Don't forget, if the radicands are not identical, there's nothing we could simply do about that. So first of all, we're going to break down root 27. You can use your tabular method. I taught you that already, for you to understand this 100%. When you use your tabular method, so when you break your 27 down, we get the product of the prime factors. We end up having 3 times 3 times 3, just like this. Very, very important. You have to note that. So we pick these two together. So this is 3. So what do we have? This 3 root 3. This is done already. We worked on this in the previous association. So the next we have is root 20, where you break root 20 down. You end up having 2 times 2 times 5. So pick this 2 out, this 2. So what do we have? This 2 root 5. We're done with that. So the next thing we do the same thing for root 48. This root 48 here. When you break root 48 down, you can use your table. You can use your tabular method. This 2 times another 2 times another 2 times another 2, which is 16, then times 3. So what do? We pick this 2 out. 2. Why? Because they have a partner. Don't forget, this one doesn't have a partner. So what do we have? We have 2 times 2, 4. 4 root 3. We're done with that. So the next thing we work on now is root 45. Root 45 is 3 times 5, just like this. So 3 and 3 gives us 3, so that's going to be 3 root 5. So we have everything sorted already. We've converted all this simple surd to mixed surd. So what do we have? We're going to state them all out now. We've stated them all out. So root 27 is 3 root 3 minus root 20 is 2 root 5. Root 48 is minus 4 root 3, then plus root 45 is 3 root 5, then minus 7, which is the last number, a major rational number, I mean. So what do we do next? The next thing we're going to do is to bring together, we're going to be collecting the like terms. This more or less like saying 3x minus 2y minus 4x plus 3y minus 7. So we'll bring together all the ones with identical radicands. This 3 will be brought together with this and this together. So that is 3 root 3 minus 4 root 3 minus 2 root 5 plus 3 root 5 minus 7 right here. So what do we have next? They are the same. 3 minus 4 is minus 3. So minus 2 plus 3 will give us, that's plus 1, which is, I'll refer to that, then minus 7. So from here, what do we do next? So this simply minus root 3 plus root 5 minus 7. There's nothing we can do about those two. They are different radicands, so we can't combine them together. So at this very point, this is our final result. Okay, guys, it's time to work on multiplication of surd. Now, don't forget there's something we have to note first before we carry on this. Now, when it comes to multiplication of surd, the radicands don't matter here. Now, when it comes to multiplying surds together, we don't really care about the kind of radicands that we have, unlike the addition and subtraction, whereby if the radicands are not identical or the same, there's no way you can combine them together. Now, when it comes to multiplication of surd, we don't really care about if the radicands are the same or not. What we just care about is for us to solve each of the stuff given to us independently. What do I mean by that? Yeah, I have a rational number here, I have my radicand, I have another rational number, and I have my radicand. Now, this my rational number here has a positive sign, this plus 3. This one here has a positive sign plus 2. So what I have to do here is to solve the rational number separately, and after that we solve the radicand separately. So yeah, we don't have to have the same radicand for us to combine them, unlike the addition and subtraction that was earlier talked about. So what do we do here? This plus 3 times minus 2. So we're going to work on first the rational and the other rational. So the plus 3 times plus 2 will give us plus 6. That is done already. Then root 5 times root 3. You need a basic knowledge of indices also, very important. So this root 5 and this root 3, that will give us root 15. So what do we have here? You have 6 root 15. 6 root 15 is our final result. Here's our second example on multiplication of surd. Now here we're going to be dealing with a major compound surd. So that's 3 root 2 minus 5 root 3 in bracket. Then multiply another set of major surd in bracket. That's 2 root 3 plus root 2. So how do we solve this? This is very, very simple. Don't forget that the radicands that we have does not determine if you can combine this set of surds together or not. So the first, this 3 root 2, we talk to this and talk to this, as it's going to multiply each of them. When we're done with that, then we take up minus 5 root 3, which will talk to this and talk to this. When we're done, we combine them all up. So this 3 root 2 first, this 3 root 2 times 2 root 3, that's the first thing. We're expanding. So 3 times 2 is 6. Root 2 times root 3 is root 6. We're done with that. That's the first step. So next, 3 root 2 times root 2, that's the next. 3 root 2 times root 2. This root 2 here has just does not have a major rational stated, but we know it has 1. So 3 times 1 is 3. Root 2 times root 2 will give us root 4. Now root 4 is a rational number. This rational, so that's 3 times root 4, which is 2. 3 times 2 is 6. That is sorted. So we're done using 3 root 2 to multiply what we have here. So the next thing we're going to be using is minus 5 root 3. So minus 5 root 3 times 2 root 3 on this end. So what do we have? We're going to work on first the rational numbers. Minus 5 times plus 2, which is minus 10. Root 3 times root 3 will give us root 9. So that's minus 10. Square root of 9, which is a rational number, is 3. So minus 10 times 3 is minus 30. So we're done with that. So the next is minus 5 root 3 times root 2. Minus 5 root 3 times root 2. So what do we have? This root 2, actually you have 1 rational. So minus 5 times 1 is minus 5. Root 3 times root 2 will give us root 6. We're done. So the next thing we have to do is to bring them all up. Just bring them all together. This 6 root 6. Then plus 6 minus 30 minus 5 root 6. So this has the same radicand. This two here have the same radicand. So we'll bring them together. Plus 6 and minus 30, we just bring them together also. They are both rational. This 6 root 6 minus 5 root 6 plus 6 minus 30. So 6 root 6 minus 5 root 6 will give us 1 root 6, just root 6 like this. Plus 6 minus 30 is minus 24. So that's how to go about multiplication of surd. Okay guys, it's time for our take home. After what we've learned in today's exposition, it's time to see how much we understood from what we learned today. So yet we have two questions to get us tested. So the first is root 27 minus 3 plus root 28 minus root 75 minus root 63. So the next question, the first one is a set of plus and minus. So the next is multiplication of number of surd, I mean. So there's 5 root 3 minus root 2 plus 1 in bracket. And another bracket open up. 2 minus 3 minus 5 root 2. So I would love you to solve this set of questions and leave your answers in the comment section. So if you found it very resourceful, please subscribe to this very channel and share this exposition. Thanks. See you in the next exposition.